and today we'll be seeing one of the problem from lead Codeforces, and it is Taisia and the dice. So the problem goes like Taisia has n six-sided dice. Each face of the dice is marked with a number 1 to 6, which means these are the regular dices. Each number from 1 to 6 is used once. So Taisia rolls n dices at same time and gets sequence of value a1, a2 and an, where a of I is the value of upper face, like value of dice on upper face. This sum, the sum of the sequence is equal to s. Okay, now suddenly Taisia's pet cat steals exactly one dice with maximum value a of I. So maximum value of item is missing now, and now the calculated sum of the values remaining of n minus 1 dice is r. R is the remaining one. You only know the number of dices n and the value of s and r. Restore the sequence, possible sequence a that fulfills the constraint. So cool, and it is said that this guaranteed solution exists for this, and we know that n, s and r. So the first line is t test cases, and we wanted to output that sequence. Like if there are multiple sequence, we can print anyone. Not a big deal. So how can we do this? Let's first understand that hey, we have such certain kind of sequences right now with us. We have 2 as a sum, and we have 2 dices and the sum is 2, and after stealing the sum is 1. So it naturally comes into my mind is 1 is 111 is the number. Next we have 2, 4 and 2. That means sum was 4, and after stealing we have 2. So one thing we can take from the intuition right now is that hey, you can get the so you can get the stolen number as s from s minus r. So that's what the stolen which you can get. So we are sure upon having the one number, which is very easy to find, right? Yeah. So now how to find the rest? That's a question, and that's a very good question, because if we have if we have n minus 1 equal to r, that means remaining amount is equal to remaining sum is equal to number of dice remaining. Then that means all of the dices are 1, because minimum value is 1, and we are sure the solution is guaranteed. But that's an happy case, man. That's a happy case. Again, one can say that. What about sad cases? What about rest? So about rest, in a sense, what I mean is, what if you have situation like let's say you have a situation like you have 4 dice, 1 2 3, and let's take one of the example right from here. So third example is good, 4 9 5. So 4 9 5. So from 9 and 5 we know that the first element is 4. Cool. What are the 3 elements? Now with these 3 elements we are sure that the remaining sum r is 5, and the count is count is 3. So possible number we can get is 5 divided by 3, which can be a possible number if we evenly distribute these numbers, but that's not possible evenly distribution, because 5 divided by 3 is not an integer number. The closest integer number we can get is 1 here, lowering down the value to lowering to the floor value. Now let's say we have now 4 we choose the one which we got from here, and we have rest of the two items. In this case, now the remaining would be 5 minus the one which we have used, which would be nothing but 5 minus 1 is 4, and now we have remaining as 2. Now possible is 4 divided by 2, which is equal to 2, and which is very much possible to have. Now we can have 4, then we can have 1, then we can have 2, and the rest is remaining. And now you can also do it again to understand that hey, the next item which was remaining can be 2. So with this logic, it's pretty much simple. This kind of pattern is known as greedy pattern, where we know the remaining amount what we have, and I'll take n as count, or I'll take c as a count for rest of n minus 1 items. Int r is r itself, r is provided to us. What I'll do is I'll run this while count is greater than 0. So at least one element I'm having, or at least the count is 1. I wanted to run this loop. What I'll get an average. I'll get an average from the remaining amount to c. Yeah, once I got the average, what I'll do is I'll sb.append. So sb is my result. I'll get this right into the results, and I'll do some bookkeeping. I'll do some adjustments. Whereas I'm using now average, I'll remove this average from sum, and I'll remove one count. Now, once this is done, what happens here is I have already inserted the stolen element. I am inserting the rest of the elements, and these elements are being appended to this string builder, and string builder is being used to send the result. So this is what, okay, Java C, let me compile this quickly. Okay, there's nothing in that append. It's append. So Java C, it compiled well, and it Java to run this. I'll just quickly copy this out, and I'll place this and this in between. So these two are side by side now. Copying out this to paste it over here. And yeah, we have the outputs here: 1 1, 2 2, 4 1 1 2, which is somewhat very similar to this, but it satisfies the solution. It is one of the existing solutions. So 6 2 3. One way you can just tally it over there, and yeah, that's where we can get the answer. I'll copy this to my desktop, where I'll okay, the name of the problem is 1790. I'll quickly submit this problem with Java solution here. I'll choose a file which is within desktop and run this. Codeforces takes a while, I guess. Now I've tried this problem at very prior days. It was to 2019, I guess, 2019 or 2020, and it's been few years now. So well, the code is running. I guess it will pass the rest of the test cases, as the problem statement is more like a greedy problem statement here. So you can see the tags. So no, it was 2023 and now it's 26. Okay, happy new year. It has submitted. So greedy and math, it is not very highly rated, it's a 800 problem, but yeah, asking in the division 3 as B. So this was all about it. For more such video, click the video on your right, and I'll see you in the next one.